I am Sergey Ananyan, and I represent Megaputer Intelligence. I'm one of co-founders of the company. We are the providers of the software, no-code, low-code platform for performing data analytics and process automation called PolyAnalyst. And today with me, I have a talented young scientist, Sam Montgomery, that will be helping me with showing some of the examples. So for those, yes, thank you, Sam. For those of you who are not familiar with PolyAnalyst, this is a low-code platform for the analysis of structured data, text, and voice. So we can do speech-to-text as well. PolyAnalyst helps automating different business processes with ETL, extract, transform, and load, machine learning, artificial intelligence, NLP, and BI tools. So you have a large library of actions to select from. And these actions are represented by icons that you can drag and drop to build multi-step data analysis scenarios. And these system is self-documenting, so once you create the scenario, it can be scheduled for automated execution at a later time. So what we offer is advanced analytics out of the box, and the system can be also used as an analytical core for some external services. So we can create web apps that your customers will be using. In addition to that, PolyAnalyst offers a built-in interface for creating reports and dashboards, and that's what you see at the lower side of the screen. So when you work with the, it's a client-server system. When you work with the analytical client, you have a library of different actions on the left that you can select from. They are all represented by icons. And PolyAnalyst supports data loading from disparate data sources, ranging from databases to different formats of files and many more sources. It also offers a collection of tools for data manipulation, transformation, and cleansing. And you can switch between different windows here to see the necessary set of tools. It supports text analytics, machine learning, visualization, and exporting of the results. So you take the nodes from the left, drag them to the right, and this is how this scenario is being built. The data flows through arrows, and arrows also show the flow of control of the execution. Once you are done with this, you can take any of the nodes that you created and pass them to the reporting engine. Here you can drag and drop objects to create the dashboard of your liking, and when your users come to work with the system, they can go to a particular website and they will see some preset collection of graphical objects, and the report is interactive. PolyAnalyst now offers a collection of tools for artificial intelligence, so we can provide connection to different LLM models that are coming from commercial providers, and you can access about 30 different models through a single simple interface that Sam will be showing shortly. And we provide the prompt building interface where you can create not only typical prompts that you use for working with AI tools, with LLMs, but you also can create dynamically changing prompts that enable collaboration between different LLM models. So the system also supports different capabilities like speech to text. It can perform transcription of different conversations to text, and it supports vision language models in our OCR module that is also provided with PolyAnalyst if you have to deal with scanned images and convert them to some extract information from them. Our OCR can do this. So it can work on typed documents. And with vision language models, you can also extract information from charts and convert them to tables that you will be able to query. And the idea of today's presentation is to try and show you basically from scratch how to use the AI connection capabilities in PolyAnalyst and build a simple agent powered by an LLM. And then we will try to use the example that we provided to actually build some useful business solutions. So with this, I probably pass the microphone to Sam, so he can show us the project that he would build in front of you using PolyAnalyst with the LLM. So Sam.
All right, thank you very much, Sergey. Here just a second, I'm about to start sharing my screen. And oops, just a second, I need to reshare. I think that I used the wrong settings. Mm-hmm. Window, and there we go. Should be the right share type now.
You need to click the button on what you are sharing. Yes,
yes.
Now we can see you.
We got it. Sorry about that. Mm-hmm. Okay, so today I'm going to show you a live build of an AI agent. And before we start, we got to motivate the issue. We're going to build a joke-telling agent. So the background is we wanted to hire an office comedian, but management said we didn't have the budget. So we're going to build one using AI. And believe it or not, some of these jokes are actually funny. So what we have right here over on the left is our internet source node. It's a web scraping node. And all it does is it goes to these different websites that are specified here. And these are our news websites. And it automatically grabs all of the links to articles on these websites and pulls them in to PolyAnalyst. And we can see them right here in a data grid.
Okay, so Sam, do I understand it correctly that we are trying to build a joke generator that will be, each joke will be focused on a particular news story, so it will be relevant, and the idea is to automate the entire process later?
Exactly. So these news articles are going to be the source of comedy for the agent. If we don't give it any stimulus, it's just telling jokes in an empty room. It's not going to be very funny. Let's go over here to ChatGPT, and we can see what I mean by that. Let's see. Tell me a joke. Why don't graveyards get overcrowded? Because people are dying to get in. So that's probably a joke you've heard before. That's the sort of thing that happens if you don't give it any stimulus. So these news articles solve that problem. They give it something to tell a joke about. That way we get jokes that are actually original, funny, and relevant to what we're trying to something that we can relate to. So this news article right here, apparently Nate Bargatze is going to be hosting the Emmys, and it's going to tell us a joke about that. And we've got one of these for each row in the data set, 78 in all. Great. So here's our data import. That's the source of the jokes. And what's the next step? Well, we're going to want to pull up that AI assistant node and have it write us a joke. Let's name this guy the joke generator. And we're going to go in. So this is our interface with the language models. You can just configure it much more easily than an API. So here's the list of providers that you can connect to. Look, we have ChatGPT, Anthropic, DeepSeek, Gemini, and some others. And if the one that you want's not in the list, we can actually add a custom configuration. Not that difficult. It can even run local models if you want to keep your data on site, or it can connect to a secure cloud instance if you have one of those.
So we can potentially help you set up the access to the model that you want to use on site. It can be done either through the cloud implementation, private cloud implementation of some models from commercial providers like OpenAI or Anthropic, or we can help you deploy some open source, or we provide our own MegaGPT model that can be deployed inside your secure counter, and PolyAnalyst will be able to work with this model without sending any data out. Though you would need to have a set of GPU accelerators to deploy this model. And in general, this operation will be slower than using some large commercial providers. All right, so go ahead, Sam. Sorry for interrupting.
Yeah, absolutely. But just as Sergey was saying, we're very flexible with our means of connecting to these language models, and we can handle any of your security concerns. So in this case, we're going to want to connect to Anthropic Claude. It's the most emotionally intelligent model. It's going to be the one that has the best sense of machine humor. GPT is more of a robot, won't be able to tell jokes. So and that's what I just did. We're connected to Claude 4 Sonnet. Let's set the number of threads higher. That way it runs faster. And now let's write the prompt. So we're going to name the prompt joke. And here's how we're going to proceed. First, we need to pass in the news article. And that news article is in the data set under text content. Here, let me show you what I mean by that. If we actually go back to the data set that we're operating on, here's the column. It's called text content. It contains the contents of the news article. And when we invoke that right here, that causes that column to be inserted into the prompt in every distinct row. Now that we have the news article passed to the model, we're going to want to give it a command. So tell me a joke based on this news article. The joke should be original and funny. And we have one last thing that we need to do, which is we're going to need to force the form, because after the language model replies to us, we're going to have to parse the output to get the joke. So reply using the following form. Let's give it some time to think. Or actually, let's ask it to brainstorm. This is a prompt engineering trick. I'll explain it in a second. And joke. And just a reminder, do not include any additional comments or commentary. Okay, it should do the trick. Those of you who are familiar with these language models may or may not know that if you allow them to to think before answering, the quality of the result improves, and that's why we're giving it a brainstorming step before it builds the joke. Let's execute and see what the result looks like. After this thing,
there is a question in the meantime. Is the column that you showed, will it be the source for the analysis? Is the column going to be the source for AI analysis?
Yes, exactly. So what's going to happen here after this thing finishes processing is there's going to be two new columns in the data set. One of these is going to be the prompt, which is algorithmically generated. We're going to have a different prompt for each row, and where that text content line was in the prompt is going to be the actual text content of the text column row. Here we go. So I'll show you. Here we go. So as you can see, there's two new columns. This is the prompt, and it contains the actual news article to the left. In this case, it's one about Nate Bargatze hosting the Emmys. And at the end, you see the command. This next one is the same as the previous one, except the news article has been swapped out. It's about a woman charged in a crash. And the column to the right is the AI's response. So it won't tell a joke about the woman who was charged with the crash, which is reasonable. So let's actually parse the output first before we look at the jokes. As you can see, the output was not just the joke, it had additional content, so we are going to have to clean that up. This term here is for data cleaning. I'm using a quick little regex, not as bad as it sounds. And all we're going to do is I'm going to take, let's see, dot star. This regex will do the trick. And let's turn off case sensitivity just to make the thing a little more robust. And let's check to see if it worked. Yeah, there we go. That's the joke and just the joke. Let's execute the thing. And see what we got. So here's a joke. Nate Bargatze asked every famous comedian for Emmy hosting advice, and they all said, just do you. Now he's planning to open the show by talking about how his dad once got confused by a blockbuster for 20 minutes, which might honestly be the most relatable content the Emmys ever had. Okay, so I don't particularly find this joke funny, but some people might. But that raises the second issue, which is that some of these jokes are just not funny. So we need to do something about that. What we're going to do is we're going to actually solve that problem with a second AI. This is called a generation validation pipeline. I'll show you what I mean. So this guy over here is the generator, and he builds the joke or whatever content it is that you're trying to generate, for your business. And the second guy, who's called the validator, he's going to check the work of the first. In this case, he's going to be telling us, was the joke funny or was the joke not funny? So we're going to be passing in the joke. And we can do that right here by swapping out the text content of the news article for the joke column. And let's let it know that it's getting a joke. And now we're going to want to change the command. So let's say evaluate the quality of this joke on a scale from very low to very high. So why very low to very high, not say 1 to 10? I'll explain that in a second. It's a prompt engineering trick. let's see, just so it knows, the joke should be original and funny. We want both. No recycled jokes. And reply using the following form. So why do we ask it to evaluate on a scale from very low to very high? It's an important question to answer if you're going to be building generation validation pipelines. Well, it's because language models are good with language. They're not good with numbers. If I were to ask it to assess the joke on, say, a scale of 1 to 10, it would not do that as well. I read a study a while back showing with early language models that if you ask for validation on a numerical scale, the result was basically just random noise. But if you ask to validate on a verbal scale, you actually got good results. Just one of the many tricks that you got to learn if you want to be working with these things. So finally, let's change the command. This evaluation is not really a brainstorming task like joke telling. Instead, it's more of a thinking task that'll get the model to think more analytically. And the output should say quality. There we go. And let's let the thing run. Any questions, Sergey?
So brainstorming enables instructs the system to make all possible modifications, try different options. And
well, it's just a less structured reasoning form. You know, it just as when a human would write a joke, they would just be throwing ideas out, seeing what sticks, as opposed to trying to get something that's great on the first try.
All right.
And the results are in. As you can see, we have a new column over here which contains the language model's output. And apparently it thought that the joke about Nate Bargatze was very funny. Maybe I just didn't get it. It happens. So it's probably funny to people who know Nate Bargatze. And let's see over here. Yeah, see, joke was very low. And that helps filter out some of the garbage. Now let's parse the output. Again, let's give these guys better names. Parse output. There we go. And let's get that out part parsed. Just going to want to swap that out for quality. And let's see if that does the trick. Oh, right. We need to change the column. So we're going to want to be answering on the quality, operating on the quality column. And now let's see if it did the trick. Looks like we actually got the prompt. Apologize for that. Live demos are very hard. There we go. And that should do it. Now let's see if we got it. That's why we have this really beautiful development environment, by the way. Trying to develop a regex, even a very simple regex, it can be a very hard thing. And when you have an IDE like this, makes the job a lot easier. Lets you get quick checks in. It's not like if we were operating Python, I would have to actually execute the script, include a debugging statement, and check the result. It would really be a hassle. PolyAnalyst makes things a lot easier. Great, and it looks like we have the quality assessment scores extracted as a new column. We can find out which jokes are good and which are not.
So I see that the AI added some of the assessments capitalized, some are not. So can we cleanse them with some tools in PolyAnalyst, like replace categories, maybe?
Yeah, so we can cleanse the results if we want, normalize the case. Now I would actually prefer to, let's get out replace categories. So first we're going to have to change the data type of the output. Let's make sure that it knows that the output is a string and not an unstructured text column, which could be anything.
Yeah, by default, AI generates a text output.
Yeah, a string is categorical. We can see the categories right here. Okay, so we can actually use case normalizations built in. Now everything's lowercase, and if we wanted, we could modify any of these however we like. So here's two columns that should be unified: low to medium and low to moderate. Let's just change that so that the columns are the same, the outputs are the same. And let's just call that. Yeah, we're cleaning the data. And now finally, we've got the data cleaned. We have the quality assessed. Let's filter down to only the funny jokes. Filter rows. And we can do that right here. We're going to want to pass in the quality column. The filter will be, let's see, is in list. We want only the high quality jokes. Easy as that. And running this will apply the filter.
So how many jokes were not funny? I'm curious.
So let's see this. Oh, sorry, I misconfigured the thing. We want is in list, not is not in list. Otherwise, it's just filtering out the high quality jokes. There we go. So it detected 18 high quality jokes. There were 78 jokes in total. So 60 jokes were not funny.
Okay, so even AI thought that it didn't do a good job on creating funny jokes. Good.
Yes, but you'll be surprised at how much higher the quality of these jokes are compared to just reading whatever what the first joke generator produced. These generation validation pipelines can be very powerful for improving the AI's output.
But if I'm a comedian, it's too complex of the interface for me, even if everything is pre-built. Is there any way that I can get the results somehow to my screen, maybe via email or some app? I would like to use the system every morning on the new news stories, so I'm prepared for the late evening stand-up show.
Absolutely, Sergey. So we can set this thing up to deliver content in various ways. We could build a dashboard or a web report. But if you want jokes to your inbox every morning, that's easy enough to do. So we have right here this beautiful send mail node. It will send emails right to your inbox. But before we get to it, we need to pass in the email that we want to send it to. So I'm going to set these things up eventually to send emails to Sergey, because we want the boss to start his day with a load of funny jokes in his inbox. Makes things easier for everyone. But for testing purposes, let's set it to my email address. smontgomery@megaputer.com. There we go. And now we can attach that email, the send mail node, and configuring it is pretty easy. We just give it the email. Yes, that's right. The recipients are in fact emails addresses. And what column should we include in the email? I'm definitely going to want to have the joke. I'm going to want to have the title of the news article. And let's get the URL so I can read the news article if I think the joke is funny. And here we go. Let's send the mail. Should be getting those shortly in my inbox. And there we go. Let's read one of these.
We cannot see your mailbox. You would need to share a different window.
Right. Let me reshare. Yeah, it doesn't. Okay, so I can do this a different way. Let's go over to my webmail, and if I reload, it should show. There we go.
You need to switch the video on the screen.
Right.
The screen on the left.
Sorry about that.
No, we
Can
still
everyone
cannot
see my
see you.
inbox now?
No, you switched yourself off. So switch on both. And the second one. Yep.
Apologies. Everyone can see my inbox?
Yes.
Great. So here's a load of jokes. Here's the news article is that Colorado City pays for security upgrades to some businesses along West Colfax Avenue. And the joke: a tattoo parlor in Colorado applied for a $5,000 security grant from the local government. Apparently, they wanted to make sure that the only people getting stabbed in their shop were the customers. It's a pretty funny joke.
Yeah, it's a good one.
Okay. So yeah, that's how we can start the day. But there's one last step because we got this thing to run, but we need to, in order to make it fully agentic, it needs scheduled execution. So what that means is what you got here is just a regular old AI workflow. It can interoperate with its environment, but in order to do that, it needs a human to actually pull the trigger. Once we get the scheduler to do that, it will be completely agentic. This is what the scheduler looks like. And we're going to want to provide an event. So this is going to be, we can schedule a daily execution. Let's start in 1 minute. That way you can see it happen. And great. And what event should occur at that time? We're going to want to schedule a project execution, and the project that we'll execute will be the webinar project. Good, and that means that at exactly 11:34, we're going to get the first scheduled execution. So before that happens, let's change this email to make it send to Sergey.
I do not have mine open, so you might want to use yours still.
Okay, well, that's perfectly fine. Well, you can just report to us if you get the emails.
All right.
And there it goes. Yeah, so and it's executing, and in about a minute, Sergey will get his daily batch of jokes. So Sergey, what do you think?
Yeah, it works. So now we have an automated agent that is performing the necessary type of work for us, and it can do it on a regular schedule. So
it's sure cheaper than hiring an office comedian, don't you think?
Yeah, absolutely. And here we're using just a simple toy example for doing the analysis. So, and by the way, let me try and share my screen so people will see that I got these jokes. Just a second. So if I share this window. All right, so here are the jokes that I just received based on the new batch of news stories.
I believe it's probably the same jokes that I got.
So
AI is operating twice.
All right, so here you can see these jokes. Now that we showed this simple example, of course, this is a toy example. We want to explain how this can work on some business tasks where you need more complex solutions. And one of these solutions will be the analysis of different data that you are receiving, either the results of surveys or collections of some documents. And these documents, they would need to be processed. Maybe these are product reviews, maybe these are support notes. You would like to create a taxonomy just in time for the analysis. Maybe you did a launch of a new product. Lots of customers are calling in with some complaints, suggestions, questions, and you need to know as soon as possible how this thing works. What are the main topics that you need to take care of? If you try to build the taxonomy manually, it will take you a month if you have even 100,000, maybe even less documents. So you need the system to build this automatically, but a single LLM cannot do this well. So we have to use them recursively. And in order to do this, we need to have some cycles in the system. So first, let me explain what you would need to have. So first, you load all the documents, or it can be some recordings of conversations with customers, for example, and you send it through a collection of AI LLMs. So the first one will be trying to assign a certain category to a particular document, maybe more than one. The next LLM would be grabbing the result and solving the opposite problem. It will check whether the original document actually supports the category that was assigned to it. And we need to also be checking all the time whether such categories had been already extracted on the previous documents, because the taxonomy will be growing, the set of category will be growing. And in fact, it might be growing too fast. So what you need to do as a third step, you need to be checking how, if there are any collections of categories that are similar between themselves. So we will be doing the clustering of categories. And then the next step, we will be selecting for each cluster, we'll be selecting the most informative category name that will describe all categories in the cluster. And this enables the system to keep the number of categories under control. So a single LLM cannot do this. You really have to do it through a collection of LLMs and machine learning tools provided by PolyAnalyst, because some of these tasks are not good for an LLM itself. And the system needs to support cycles, because it needs to grab one document at a time and run the entire analysis. But after it created a collection of categories, it also needs to tag individual documents with categories where they belong. So this is done in a separate AI agent. And on the output, we have the first collection, the first level collection of categories. Now, every category has a collection of a bucket of documents that belongs there. But frequently, you need to create more than just one level taxonomy, because you need to know details of what is happening. And this system can, without any human input, can help you doing that. So every category takes the bucket of documents that belong there and goes to the beginning of the cycle and presents these documents to check if this category needs to be split further to the second level, third level, and eventually, once you are doing this cycle sufficient number of times, you have the 2, 3, 4 level taxonomy that will make sense. And this taxonomy would allow you to extract, to reveal topics that you did not anticipate upfront. So if you are doing this, you can do many things with that type of analysis later. And let me show you how you can do the cycles in PolyAnalyst. This is some new and very useful addition to the system.
Yeah, and, that's correct. A lot of agentic workflows require cycles, and it's becoming very normal to need this. So okay. It's good that we're offering support.
Thank you, Sam. So here we have, I loaded simple set of data that talks about cars from different origins. So here would be the different car models that were built in 70s and early 80s, and they're coming from USA, Japan, or Europe. We would like to do the same type of analysis, but on each origin of the car separately. Again, it's a very simple example and simple use of the loops or cycles that we have. So what you would do, first we need to create the split the categories that we're going to work with. So we do the distinct analysis on the origin, and we get just 3 random records with USA, Japan, and Europe. It is needed just to get these names. And then these names of origins, we pass them through the loop start. So when you select loop start, you tell the system what to do. And here I will be working with fixed block size, 1 record at a time, because all I need is the origin. But you can do condition-based processing. You can do certain number of iterations that you can specify. So all these things are supported in PolyAnalyst, and it becomes a very flexible system. And then whatever is between the loop start and loop end, this will be executed multiple times based on the conditions that we specified. So what we're going to do here, we create a condition that first we need to separate, so we need to create filter rows that will be isolating from the original data set all records that belong to the USA or to Europe or to Japan. So in order to do this, we create the type of the filtering condition. So we tell the system that find in the origin if it contains one of the records, because we are taking 1 value at a time. So in origin, we have 1 record has USA, 1 has Japan, 1 has Europe. And we'll be checking the entire text. So on the output, the system generates this type of condition. And since we passed these 3 records to the data, by default, the system takes the last one. But when it runs the cycle, it will go through all of them, substituting 1 at a time. So right now it has Europe as origin. And now we need to parameterize the filtering node. So it's like using variables. So for this, we have the parameters node in PolyAnalyst that allows configuring the behavior, changing the behavior of different nodes automatically based on the previously calculated results. So for different nodes, you can have different sets of parameters. For filtering, you just need to use the filtering condition, and you can be concatenating or not. We don't need this. So we are just passing the filter that we just created, the origin filter. And this origin filter will be applied to the original data. So this replica of the original data helps me keep everything inside just one group node, so I have it becomes observable. So when I now pass it to the filtering node, so the filtering node automatically gets this condition, and then I want for each of the origins, I want to run linear regression to just identify how economical the car is based on all other parameters. And linear regression builds this condition. Here it is for European cars, but it will be doing it for every value that I have in the data set that I'm passing to the cycle. And then I want to score the data. So when I run this, it probably will run so fast that you will not even see the execution, but let me try it. So we do the execution. So it just finished. And on the output, the system gets the prediction of this linear regression for each type, each origin of the car. It will be using a different value. And now I can take these outputs and using the aggregate chart of PolyAnalyst, I can so use just drag and drop the icons to the x-axis, primary y-axis, secondary y-axis, and so on. And once we are done with that, you see here the comparison of the real miles per gallon versus the linear regression. So the red one, the orange one is the miles per gallon, and the beige one is the prediction. And you see the split between Europe, Japan, and USA. So we're comparing them in one shot. And in gray, you see the weight of the car. So you immediately can draw lots of conclusions. At the bottom, you see the year of production of the car. So first, during the 70s, closer to the end of the 70s, there was a drive for cars to become more economical. And in general, European and Japanese cars were more economical than American cars at the time. But American cars were catching up. They started catching up in early 80s. And the way things worked, the Europe and Japan, they had the weight of the car about the same, but in the USA there was a big trend of making smaller and lighter cars. So you see everything in one chart. So that's how the cycles work. And now that we can combine the power of automation with the power of AI, we are gaining new capabilities. So we can solve problems that previously were unsolvable, like automated generation of the taxonomy, for example. So from here, I probably will pass it again to Sam. Will you be able to show some examples of how we build taxonomies, and taxonomies become real business solutions? They can power different applications that are actually really important for the business, for the organization. So Sam,
Absolutely.
you need to switch on the sharing.
Thank you. It's on now, right?
Yes.
Great. All right. So thank you, Sergey. Yeah. So just as Sergey showed, using the loop, he trained up a different linear regression model for every country, because the variables were different. The taxonomy also uses a loop, and I'll show you how. So let's first just talk about what we're looking at here. We used as input to this analysis in this case, some responses to a survey by the insurance company. The insurance company basically just said, are you satisfied? Why or why not? And we provided those responses to the taxonomy builder, and we asked them for a hierarchical classification. And this is what it produced. Here's the top level of the taxonomy. You can see claims handling and pricing, customer service, brand loyalty, product features. All of these categories were automatically detected. So what happens if we click on claims handling? Well, what we see is another tiny little taxonomy beneath that, having only 2 levels. And these are the categories within the claims handling section. Overall satisfaction, timeliness, customer service, claim decisions, and staff professionalism and knowledge. So it seems like the AI is pretty good at knowing what the important features of the data set are. Again, we can, one more time, click on claims decision and find out what people were unhappy with respect to the claims decisions. They didn't like that the fault was put on them when they didn't feel it like it was theirs. They thought that it was unfair. Insufficient investigation, now that's potentially actionable. And coverage, they didn't like that coverage was denied. So how did we build this? Well, as Sergey said earlier, it's basically just a loop around a tagging and clustering and cluster resolution workflow. We feed in the data, we ask it to put tags on the data, and then we cluster those tags. That way we don't get duplication or of similar tags. And this is what the result looks like. This is probably, well, I would say certainly our most successful example of an agentic workflow. And it's adding a lot of value to a lot of different customers. So what we did.
Why some of the slabs are green and some are red?
All right. Yeah. So that's actually an additional layer of processing that we did after running the agent, the taxonomy agent. These taxonomic categories were used as input to a machine learning model that predicted the customer satisfaction scores. And the length of the bar represents how strong a predictor it was of customer satisfaction. And the color of the bar tells us if it was a positive or a negative predictor. For example, claims handling was the second biggest predictor, and it was red, meaning that the customers weren't very happy with how the claims were handled. Now, they were happy with the timeliness of the handling and the customer service that they got, but they weren't happy when they talked about the decision, and they feared and distrusted the process. This is in line with what we saw earlier, that the customers felt sometimes that there was insufficient investigation before a claim decision was made. So when we run this thing with the additional ML, with the additional predictor of satisfaction at the end, it's essentially just dishing out, here are the problems listed by importance, and that goes a long way towards solving them. That's just one example of how you can apply the taxonomy builder. If we go over here to a second example, this is an e-commerce customer support taxonomy. All we did is we ran the very same agentic workflow, but instead of running in surveys, we gave it transcripts of customer support conversations. You may have had such a conversation with, say, Amazon after you had an issue with your product or experience. And here are the top topics that it identified: after sales orders, shipping and delivery, product inquiries, invoice issues, et cetera, et cetera. So it seems to be hitting on the top issues pretty well. So we can click here to find out what's wrong with the invoices. This is just applying a filter, by the way. Whereas previously the data set had represented all records, now it's been filtered down only to those which discuss invoice issues. So they had issues with invoice issuance, issues with the downloads, invoice with issues with delivery and address. This is absolutely gold as far as data goes. So in the previous taxonomy, we had a satisfaction score actually in the data. The customer had rated on a scale of 1 to 5 how happy they were with the service. Now, in this case, we didn't have any such data. So we used an AI to impute it. What we did is we set the AI on the problem. We ask it to evaluate the quality of the service and to assign a service score. This was mapped from a quality of scale of very low to very high onto a scale of 1 to 5. And here's the AI's reasoning. In this case, it assigned a score of 4 to how well this issue was handled, saying that customer service responded positively to the customer's modification request and provided specific operational suggestions with a friendly attitude and proper handling, but was unable to complete the modification immediately, resulting in some waiting time. So almost...
Okay. Sam, thank you. I think that's enough about the taxonomy. You can just show that it can work cross languages. The data here actually comes from a Chinese provider. So if you can click on the, just show the Chinese records. And maybe at this time, we should try and open the floor for questions. So if anybody has questions, you can just put them in the chat, and we'll try to answer the questions. And if there are no questions, I can quickly show some additional things, just a flash of what else can be accomplished with the help of AI. So something that we are doing in PolyAnalyst now. So again, this is the same taxonomy, but we can also do the analysis. And let me make the window smaller here for a second. So for if you have some data that looks as scanned papers, we can use the OCR engine in PolyAnalyst to understand tables and even understand images. So here you can look at the chart, and this chart gets converted to a table. So here is the description of the clinical studies results with different drugs. So they get converted to a table, and the chart below is the second table, and so on. So you can also handle the results where you take some audio recording and you ask the system to perform the transcription of the audio recording. And this is an example of an web app created with PolyAnalyst. So you can see how the system parses individual speakers and generates the text recording. This text recording can be fed to further analysis in PolyAnalyst. So that's probably all that we wanted to show in the current webinar. So here would be the last chance to ask questions if you have any. And we thank you very much for attending the the presentation and look forward to talking with you. We can build some useful business solutions for your specific needs if you are interested in that. And we invite you to use PolyAnalyst platform. You can download an evaluation copy and try using the new capabilities of the system. We'll be happy to assist you with any questions. So with this, thank you so much. Sam, thanks for showing good examples, and we look forward to talking again with you in the future. Have a good day, everybody.